Hi everybody, my name is Moshe Zadka. Welcome to my tutorial about writing unit tests. I hope you already have followed the instructions and you already have all your setup working. But the first part is we'll make sure to check our equipment to make sure that everything is working so we can move on. So I'm your teacher, Moshe Zadka. We started at 3 p.m. I do want to start with an acknowledgement of country. I live in Belmont, in San Francisco Bay Area Peninsula, which is the ancestral homeland of the Ramaytush Ohlone people. So let's start the equipment check. You should start Jupyter if you have not started it already. If you installed it locally, HTTP localhost 8888 is a default. You should probably see it when it runs. It will tell you exactly. If you have not installed it locally but some other way, connect to it however you installed it. And let's make sure that it works. This notebook that I'm going through, you should have already installed on your Jupyter. And so you should be running it and you can check along with me and see that you get the same results. So the first part is we're going to use Pytest to run Pytest inside Jupyter. And the first thing we're going to do is we're going to import Pytest and make sure that it works. Autoconfig should configure it correctly. If you got an error from that, then make sure that everything is installed appropriately. If you're still seeing issues, this is a good time to go to the troubleshooting notebook and check if everything is okay. Possibly the virtual environment doesn't have Pytest installed. Now that this works, let's start running tests. This is what we'll be doing most of the tutorial, and most of our tests will fail. This is good and right and should happen because we want to make sure that our tests fail so we can see how failures look like and how we can make them succeed. So let's run our first failing test. This test will parameterize this value just to kind of see that it can fail twice. So this is how assertions are going to look like. Like I said, we're going to be failing the test, so we're checking that something is not equal to itself. That is going to be a failure. And here we see how many failures. FF showed us there were 2 failures. And here we see the first failure. 1 is not equal to 1. And here we see the second failure. 2 is not equal to 2. We see a summary here and 2 failed. This is going to be the kind of things we look at a lot during this tutorial. So now I want you to run it yourself and make sure that the same thing happened, that you saw the same 2 failures. This video will pause now for 5 seconds. We'll see some neutral background, and I'll come back to you in 5 minutes and make sure that everything is working and we can move on. So please take the time to make sure that everything is working. If there's any issue, please contact me on the chat. everybody, welcome back. I hope everything went okay and that you managed to reproduce the same failure as you saw above. If you did, great. If not, when you do the next exercise, try to catch up and see if you can get things configured again. And now let's move on to talk about assertions a bit. So let's start by looking at an example test, right? All our tests will start with this. This just tells Jupyter that this should be run under Pytest. And here's a test. It's just a function. And in that function, we have an assert statement that checks that 1 is equal to 1 plus 1. As you might expect, 1 is not equal to 1 plus 1, and we get a test failure. This is probably not surprising, but this is how tests look. And let's kind of dig into like some of the inner working of the test, and specifically the assertions. So if you think about it, a test is a combination of two things. You need to run the code that you're testing, what is sometimes formally called the system under test. But after you run it, hopefully it didn't raise an exception, which is great. But you probably want to say something more about it. It needs to be less than something, bigger than something, equal to something. If you have no idea what you expect, it's very hard to test. So you want to check that the results are correct. Assertions is what checks the result correct. In Pytest, use the assert statement. Assert statement is a built-in part of Python, but this is what Pytest uses also to check the assert. The statement just checks that the input is a true C value, and otherwise it will raise an assertion error. Here we go. So we can use assert even without Pytest, and we'll get a reasonable exception. You can add a string value, in which case you'll get a little bit more. And of course, if you assert something true, no exception will be raised, so we should not expect any output here. This is usually how assertions work when Pytest is not involved. However, when Pytest is involved, it will change the assertion. So it's not just going to raise an assertion failure, it's going to start outputting some interesting information. So here's an example, right? We assert that 1 is equal to 0, just as before. Now we don't just get like the values here, we also get that I expected 1 and I got 0, right? So this is a little bit more information, and as we'll see, sometimes Pytest will give us a lot more information. In general, it tries to give whatever information it thinks will help you. It's somewhat heuristic and sometimes tries to guess a bit, but it's usually very useful information. And because it's useful information, it's useful to know how to read it, how to get the most out of the information. So the first part is the running output. You'll sometimes see this in a build log on the console as the tests are running, especially if you have a lot of tests. In this tutorial, mostly we'll be running 1, maybe 2 tests at a time, so it's not going to be interesting. But when you have a lot of tests, it's useful to see the running output. The running output looks like this, right? Especially if you do it with high verbosity, it will print each test. Here I only have one test, so one test reached 100%. If I had more, if I had 100, then each one of those will increase the percentage by 1. The next part is the failure details. This is usually the part you want to concentrate on. After you have seen the failure, you want to figure out what went wrong. If you have more than one test that failed, you'll have different test failure details. And this shows you details about the failure. You'll see a little bit of the code. You'll see the values of the relevant part of the assertion. And sometimes, depending on whether it's meaningful, you'll see a diff. So, right, we see this, right, like it's the name. We see a little bit of the code, right? Not just the assert statement, but the function, right? And if there were a few more lines, we would have also seen them. Then we see the values, right? That 1 plus 1, right? It's hard to do it in our head, we can see that it's 2, and especially when it's variables, this is very, very useful. And finally, we see a diff. right? And in the end, we get an assertion error. The last part is a failure summary, and just shows you how many tests succeeded and failed. This is a good first gauge to see what is the situation. So obviously, if everything succeeded, this is great. And if only a few things succeeded and some things failed, you know that you have broken everything. And if only one thing failed, you think, okay, well, I probably broke the part that this test is testing. So here's a more interesting part. We'll see a few failures and a few successes, right? So as you can see here, the running output is a bit longer. I have failed, passed, failed, and because it's 3, then I get 33, 66, 100. I still get the snippets for each one. You'll notice that if it's not an assertion failure, right here, the assert statement wasn't reached. It couldn't get reached because 1 divided by 0 already raised an exception. This happens, and this is important because this does not give you further information, right? When you have an arbitrary exception, you will not get more information. So this will happen sometimes and you have to debug it, but try to plan your tests so that if something goes wrong, they will fail an assertion before doing something that can raise an exception for unrelated reasons. And remember, tests by definition run on your buggiest code. They'll help you find bugs. So when you're writing the test, assume that the code is very buggy. So a succeeding test is not mentioned in the summary, but it is counted. So you see that we got 2 failed, 1 passed, but only the failures are mentioned. That's very useful because, again, if you only broke a little bit of your code, you probably don't want to see all the successes, but you do want to see the failures. You will see all the successes in the running output because at this point, you want to see what progress has been made. So the first assumption we'll cover is equality. Equality is the most popular assertion because often, at least in certain cases, you know that you expect a specific value. So let's say that you have a function that implements addition, and it has a bug. Ideally, your function may be more complicated, but sometimes it also have bug. Our function, makes a bit of a mistake. It adds 0.1 instead of adding 0. So let's see how this failure looks. Right, this is a reasonable assertion. Right, we want to check that 3 plus 4 equals 7. But it will fail because we have carefully made sure that add has a bug. Right, and you'll notice that not only do we see the values here, right, that are in the source code, we see the return value is 7.1. This alerts us to the difference and then says, well, I got a 7.1 and not a 7. So that's unfortunate, and now we have to debug this problem. So even though this example is very short, there's still some things to unpack. We compared add to the expected result, right? Because this is what the function was supposed to do. We knew what 3 plus 4 is meant to do, right? Maybe usually we pass much bigger values that it's harder to do in our head, but we test it on small values and we know it's supposed to be 7. We didn't care how we implemented add. There are other possible implementations of add, and we would still test them the same way. So let's check another way to implement add with the same bug. So this is an alternative, right? The implementation here and the implementation here look very different, but they actually, do exactly the same thing, and they will fail in the same thing. And not only will they fail in the same way, from the perspective of the test, you'll get exactly the same failure, right? So this is, even though this is a very simple function, this is how you want to write tests. You want to write tests without assuming anything about the implementation. You want to write the tests while you try to figure out what actually went wrong. So the test only checks add against the documented guarantees. The documented guarantees is that when you give add to arguments, it will return their sum. In this case, the documented guarantees are very strict, right? 3 plus 4 has to be equal exactly to 7. Right? So this test works well with an equality assertion. This is great, and this will sometimes be the case in your code, right? That, the guarantees that your functions have are strict enough that at least in certain cases you know exactly what it's equal to. Now, sometimes you want to compare lists. With lists, there are 3 potential things that can happen. The list on the right might be a proper prefix. And here's an example, right? We check that 1 is equal to the empty lists. You notice that it says the left contains 1 more item, right? Because we have 1 more item here. The list on the left might be a proper prefix of the list on the right? The exact opposite, right? So now we have 1, but it needs to be equal to 1, 2. So right contains 1 more item, 2. And if one is not a prefix of the other, there'll be a first element where they differ. So here's an example, right? We have 2 lists, 1, 2, 3, and 1, 4, 3. And the second element is different. In that case, it shows the diff, right? So a list might have extra elements, might have missing elements, or an element in a given index might be different. And these are the 3 ways that the list can fail, and these are how the failures will look like. These failures are different. They're different from one another, right? Here we have a diff. Here we see an extra element, and here we see a missing element, right? If you know how to learn to tell the difference, if you read it carefully, you will get a lot more information. And this information is crucial because it sometimes will fail in CI, and you want already to have a pretty good idea of what's going on when you're starting to debug. So, it's very common, of course, to expect to compare strings. For all kinds of reasons, and often you have a strict equality guarantee on the strings. So here's an example. We'll check the string hello world against goodbye world, and again you see that it has diff. It tells you that the world is the same, but you greeted it with goodbye instead of hello. Well, this is one benefit of the new line. It will also do partial diffs as the strings are long. There are some heuristics. Hopefully it will be easy enough to read. It's unfortunately not very easy to control, but it usually makes the right choice. So here, if we have a very long string, right, then you'll see that the string begins and ends the same way. And so it's kind of very hard, to read. But it points you to the exact place where the difference. Right? If you look at the assertion error, it's actually completely useless because it has 3 dots exactly where the interesting part is. However, this shows you where the failure is. We have goodbye, where we should have had hello. Pytest will try to give useful diffs with most containers, not just lists. So here's a little example of a set. Right? It has extra items in the left set and extra items in the right set. Sometimes it will give you more diff depending on how many VVs you give it. So this is very useful. And one trick that is very useful when you debug things, I just warn you that you don't want to raise exception accidentally. But raising exception intentionally is a very powerful way to debug tests. And the reason is because you know that the exception will fail the test and show you the output regardless of what else is going on. So this makes sure that the test fails, and if you see that the test doesn't fail with your exception, you know that something is weird is going on. Maybe you're writing code and you're actually debugging different code, or maybe something else is going on. Maybe it's not even running your function. You know that it's supposed to fail, and the exception to test failure output is the most reliable output path. You might write logging or you might write printing, but those can get sometimes swallowed by all kinds of testing frameworks around Pytest or inside Pytest or by Pytest plugin. However, the exception has to result in a test failure output. So this is a very reliable way to see what's going on. So here's an example. Here's a little function that trims 1 when it should have trimmed 2. And let's test it. So you see that test subtle manipulation shows us a diff, but the diff is a little bit hard to read. However, the erroring just shows us both things plus the value of the trim, right? And we can insert that error into a function, right, into the system under test, and know that we get the right value. So this is a good way when you're debugging to just, literally insert bugs into random places and figure out what's going on. Now, equality is not the only assertion, although it is by far the most popular. But there's other assertions. For example, there's inequality. Inequality is usually a helper assertion because it's the only thing you can say about two things that are unequal. Again, that's not a lot of things you can know. Of course, with inequality, you don't have a diff because you expect a diff. So all you get is just the values. But still, it is useful to see that on one side you got 1 and one side you got 1.0. That might indicate the nature of the problem. Of course, inequality is not for numbers. And again, it's useful to know what kind of outputs to expect. Here are two lists that happen to be equal because one is a copy of another. And again, the best Pytest can do is just tell you, well, I'm seeing the same list twice. You notice that in the code here, it says X. However, when Pytest open it, it actually shows you the list. So regardless of how many steps you have between that, you'll actually see the value of the list. Sometimes the best thing you can do is order. Equality, less than or equal to are often popular assertion. You have an upper limit about how something can be. This is an example of a failure assertion. Again, not much Pytest can offer with a diff, but it can show you the actual values that it's trying to compare. Always think about which ordering operation you want, because less than or equal to are of course different, and you want to make sure that you know what you're expecting. So here we go. Again, Pytest will try to give you as much information about the test as possible. You can also compare sets for less than or. However, with a little bit of set theory, you can actually make the test failure much better. Here, this is kind of hard to read. Sure, in this case, there's only 2 things, so I see that the 3 is missing. But imagine that there were 100 things. It's kind of, gets confusing very easily. However, if you compare the sets like that, if you check that the intersection of the smaller and the bigger is equal to the smaller, then you actually get the diff. This is very useful. In and not in are, of course, also very useful. Sometimes the only thing you can tell about something is that it's equal to something. And here, it does try to give you, again, as much information as it can. For example, range 0,3 and how we got to range 0,3 from range 3. Again, if it will try to tell you how it got to a given set, that's very useful. And this shows you that you want to put as many details on the assert light as possible. Is a very complicated operator already, but if you need it, then you can use it. You notice that this is supposed to fail because these are different things. However, this has to be the same because we created the string only once. So this fails. And this fails as well. All the comparison operators in Python test chain, Pytest special cases comparison chains. So look at this example. I compare x to two things. Of course, the first equality should succeed and the second shouldn't. Let's see how it looks. Sorry. Pytest will find the first non-matching chain, and we'll focus on that and show you the problem. Sometimes there is a direct Boolean that you want to assert. In those cases, you want to put the where you got that Boolean on the assertion line to get more information. So as you can see, here the test failed. And while you did see false, which doesn't tell you a lot, you already knew that false is not true. Now here you see that it calls a function called always false, and you see the parameter. That's, again, very, very useful if you want to know what value, especially as you can see here, the logic is complicated, but you see the final result of what it called the function with. So this is very useful. And now we'll shortly break for an exercise. So we will pause for 10 minutes. You'll notice that each of these things has a specific line that tells you which line you're supposed to fix. So all the other lines you should keep as possible. Keep the same. Do not change them. And when we come back, we will solve these exercises. So you should have 10 minutes. So see you in 10 minutes. Hi everybody. I hope you all felt like you had a good chance to try solving the exercise. And even if you didn't finish or you got stuck, that's absolutely fine. The fact that you try to do it will make it easier for you to absorb what I'm saying as I'm solving the exercise. So that's always good to try a little bit. But with that out of the way, let's see how I approach the exercise. And so the first thing I'm going to do is I'm going to try to run the test as is. Maybe I don't have to fix anything, but even if I do, this way I know what to fix. And as always, the first thing I'm noticing is that one test passed and one test failed. So that's good to know, because now I can address the test that failed. So let's, right, the test that passed is not interesting. Let's read the test that failed. Okay, well, it called safe remove things, and it asserted that 2 is not in things, and 2 was still in the dictionary. And that makes sense because safe remove doesn't do anything. It's literally just a pass. So it makes sense that it didn't actually fix it. Well, it's called remove, so I probably need to remove A from B. So let's do, something like A pop B, right? A is going to be a dictionary, right? Because it's passes in a dictionary, and B is going to be some keys. So that looks like it's good. As you can see, I only changed the line that I was supposed to fix, right? And that made the test that failed pass, but now the test that tried to pass failed. So let's see. So it didn't. What happened was it gave it a key error because I'm trying to pop something that's not there. So there's a bunch of ways to fix it, but of course I can go back to doing nothing. But that again will make the other test fail. So I need to move something that, okay, so that's what safe remove means, right? I need to remove it, but it's safe if it does nothing. There's a bunch of ways to do it. One of them is, so you do that. And that made the test pass, right? So the important thing is not the fix itself. The fix, you can, do it with an if, you can add the other argument to pop. But whatever it is that you do, right? Like the important thing is to figure out that you need something non-trivial in safe remove and to make sure that both tests pass. So this is the flow. This is how you try to fix tests. And now let's move on to the next one. So again, we'll do the same thing. We'll run it. And okay, again, one test failed, one test passed. Let's look at the failing tests. Okay, so it expected that these two things will be the same, but it is. But it also expected that A is less than B. Okay, so maybe I'll just return first B and then A. That looks like it will fix this test, right? And it did fix that test. But now it fails the second test. So that's not a good thing. And now I say, okay, well, I'm looking to see that A is less than B, right? So maybe I'll just, always return two numbers. And now it fails that assert, right? It tries to make sure that okay, so there's all kinds of ways to fix that, but the right way to do that is to look at what the test says and to just do that. Right, this way I still always return the same two things, but this thing will always be smaller than this thing. So let's check, and indeed that fixed the problem. So again, this is very common, right? And this is also common in real life, right? Some of the tests pass and some of the tests fail. You have to be careful as you're fixing one test not to harm the others. So kind of let's wrap up this part. Tests include two parts: running some code and verifying. Running is basically just calling functions or classes or whatever that you define. And assertions is what helps you verify. And Pytest rewrites the assert statement, so it's very useful to use it because you get high quality failures when it does fail. And now it's time for a short break. So the video of me will pause. There'll be some neutral stuff playing, and we'll come back in 10 minutes. So see you in 10 minutes. Hi everybody. I hope you enjoyed your break. And until now we covered how to do the verification part of the test. We tried to figure out how to do asserts exactly. But now we go to running the tests. We said that you're calling the functions. And that works well if the functions were the kind of stuff that I showed before, right? Like some things that handle data structures or numbers, addition, subtraction, right? Mathematical functions, if you will. But as soon as we start writing code that interacts with the real world, which ultimately all code should do because it needs to do something useful, then you'll find that you don't actually want to interact that much with the real world in your unit tests because they're running on buggy codes, and you probably don't want your buggy code touching the world. And so you have mocks. Mocks replace the world with a world of mocks that your code can safely play with and not do harm. Kind of with that bit of theory out of the way, let's see how these things actually turned out. So you can find the mocks in the unit test mock in the standard library. So it's part of the Python standard library. You don't need to pip install anything for that. You will usually use magic mock. This will be the main one that we cover in this class. I'll talk a little bit about other things and why they're often less necessary. And so in order to see some mocks in action, let's start failing some tests. And of course, the best way is to just test a function to raise an exception. So here's a function that raises an exception. And we're going to raise a mock, and let's see what it gives us. So as we expected, we got a failure. And you see that the value error, right, has magic mock and some ID. And this is often how mocks will look, right? You'll see a mock with some ID. That's the default, and we'll talk about how to change it to be a bit more useful, but it's important to know how this works when you do nothing. So mocks have every single attribute, and that attribute is also a mock. So again, let's see how this works. Here I now call the function again, just like I did before with the mock, but now instead of raising value error of x, I raise value error of x dot some name, and clearly this is a made up name. And even though I did it, I'm not getting attribute error, right? I'm getting the value error, and you'll notice that now I'm getting a name, and the name is mock.someName, so it kind of documents the path it took, and again some random idea that will be useful if you want to know if two mocks are identical or not. So the mocks attributes are consistent. So retrieving the same. You can imagine that it can't actually have all the attributes because that would take, more or less infinite memory. But once you get an attribute, it will remember what it gave you, so it will pretend like it really does have that attribute and it's consistent. So let's see how this works. We're getting a mock, and we're going to check that this is not that. So if I'm correct, that test will fail, and we'll see how it failed. So indeed this test failed, and you see that the assertion failed, and because these two objects are the same, right? And you notice that they got from the same mock where this, and this is like really useful to learn how to read that kind of failure, right? This is why I did not put the calculation of obj.someName before it. I actually embedded it in the assert statement, so you can tell me how did I get to obj.someName and how did I get to this obj.someName. Well, I got it from the from that mock, which ends with ID 968 and .someName, and even though I retrieved the attribute twice, it gave me exactly the same object, right? The object was ID ends with 760. So that shows you that indeed when you get the same attribute twice for a mock, you get the same thing. Now you can call a mock. This is very useful because often you want to, pass in stuff that you can call. Here's an example. In this case, we're calling x and we're raising the value of that. let's see how that works. Again, so you notice that now I have these parentheses. These parentheses are new, right? Like before they have that mock dot. Right now I have mock parentheses that shows that this is a result of trying to call a mock. And just like getting an attribute, calling a mock is consistent. It will return exactly the same value, identical, not equal, but identical. And again, we can check that by calling a mock twice and checking that it is not. And as you can see, we got 920 here, 920 here, and they're getting from the same object, right? So this shows you that calling a mock more than once, and this might surprise you a bit more, right? Because you expect that when you get an attribute twice, you will get the same attribute. But in this case, even though we called the mock twice, we still got the same value. So this is important to remember. And we'll talk about how to override it later, but it's important to know how the defaults happen. So remember, an attribute access returns a mock, and mocks can be called. Now, in Python, a method is just an attribute access plus a call, which means that a mock also has all the methods. So let's try to call a method. So we'll call that method, and then that should return a mock, right? Because again, we talked about how when you call a mock, you return a mock. And so we should be able to access every attribute. So let's see how that looks. Okay, so it shows you the exact path it took. You got some attribute. You did not call the mock, right? You got some attribute. Then you called that attribute. Then you called that method. And then you got an attribute of a different name. And again, because all of these are consistent, even if you do them all together, it will still be consistent. It will always return to you the same mock if you follow the same path. So this is cool. You can go as deep as you want. Now, the reason it's called a magic mock is because mocks also have all the magic methods. These are methods that allow overload operators. For example, you can add magic mocks. So let's try to add one to mock and see what we get. We raise the value of 1. So this is interesting, right? Again, adding in Python is pretty much the same as calling the dunder method add. So we call dunder add, right? And this is just, fancy syntax for that. So that's not surprising. What might surprise you is that I already told you that if you call a mock more than once, then you get the same result. And that means it doesn't matter what you add. So, as you can see here, I'm adding 1, and I'm checking that it's not equal to when I'm adding 5. And if mocks were at all reasonable, this would be true, but it is not. They are in fact equal, right? And the reason they're equal is because remember that what you get when you add is just mock.dunder add and the call of it. So it's not surprising actually that x plus 1 is the same as x plus 5. And this is again important to remember because this will surprise you, right? Because they don't behave like anything reasonable. You can iterate over values. It won't raise an exception, but it will immediately terminate. So here's an example, right? Like we will raise an error as soon as we get an element. And we don't get any elements. As you can see, we get to this statement. If we get to this statement, it means that this statement has never been executed, which means there are no items in X. So you can iterate it. The iteration will work. It just will go into the for loop zero amount of time. So you have iterated over an empty sequence. So when you treat them as a sequence or as an iterable, more accurately, they're just an iterable that has 0 items in it. And the reason I said not exactly a sequence but an iterable is because you can use the bracket operator And you can use it with a lot of kind of syntax, and it will always return the same thing. So as you can see, I have a little bit of a test here. I do x of 5. I do x of 5 to 7, x colon colon minus 1, which is how you reverse a sequence usually. So let's try to test all these folks. And as you can see, they're all just mock.under get item. In this case, the mocks are different because they're all created separately. But if they were the same mock, they would also be the same value. So they're all basically raising mock.under get item. And that's because internally in Python, all these operations just map to get item with a weird slice. But since, again, like by default, it doesn't matter the argument with which you call. It will just return the same value. So calling the mock just returns the under get item. You can name a mock. This is pretty good because it will make the errors much easier to read. And here we're writing, we have a little bit of code. Not very interesting and also, of course, buggy because all my code is buggy, so it will raise a value error. But as you can see, here there's an opaque test. It doesn't have names. And here there's a clear test. And let's see what the value error here tells us. The value error says that source, we raise value error with source target, but okay, that ID looks okay. That ID looks okay, and the read looks probably okay. Now let's see what happens when we test the clear. Remember that we call the same function, right? These tests are identical, except for the fact that they name or don't name their the mocks. Now let's look at the clear test. Oh, wait. Here it raised source and it got the mock that's called target. And target is a mock called source and it's trying to read from the target. That's clearly not okay. And if you look very carefully here in copy stuff, I wrote target source, but it should be source target. So that's a mistake. But again, when we figure this out, it's much easier to figure it out when you see that someone tried to call read on a target, and that this matches to target and this matches to source, right? It's much easier to see that there's a problem here. So in general, you want to name your test so that if there's an exception or something raises or you have a log line or whatever, then you have more information in the mock wrapper. So here you can see them side by side, right? These numbers don't really mean a lot, but when you have a target and a source and a target.read, that makes a lot more reasonable. That says, you shouldn't read from a target, you should write to the target. Clearly, like some inversion goes on, and then you can go look and actually find the bug. So far we just talked about how to use the properties. Sometimes you'll want to set, a property specific value on the mock to actually pretend to be something. So here's an example. I can just set an attribute to 5 and then check. Accidentally. Here we go. So I set this attribute to 5, and then when I check that it's not 5, you see that some attribute is indeed equal to 5. So setting a mock's attribute removes it now. Don't know that x dot some attribute is no longer a mock. Now it is just the number 5. If I try to get some attribute from 5, I cannot, right? Unless it's an attribute that numbers happen to have. So we can override it and set any property. You can also set the attribute in the constructor. I actually recommend it because this way you don't first create the mock and then fix it. You just create it correctly to begin with. A lot less chances to add mistakes later. So here, I'm setting an attribute 5 here. And now you can see that the mock thing dot some attribute is equal to 5. That's great, right? So this is in general better. You can also set deep attributes that violate what is not actually a law of Demeter, which means you might want to set the attribute of an attribute of something, right? And you can do that because until you actually set it, everything in the path is a mock, right? So some people argue that the test is not truly a unit test if somehow the code tries to get the attribute of the attribute. I feel in general it's somewhat of semantic hair splitting that is not ever going to be useful to you. If the test actually tests something useful, then just go ahead and write it. So here I set some attribute dot value, because remember, by default some attribute is a mock, so I can set that mock's value to 5. And remember that mocks are consistent, so x dot some attribute is going to give me the same mock, and since I've already set its dot value attribute to 5, I should be able to get 5. And you can see that if you take thing.sum attribute and you get its dot value, then it will get 5. So that worked, right? And you can then set these deep properties. Now earlier I said that you usually want to set these things in the constructor, but setting this in the constructor looks a bit difficult. And it is, there's a little bit of a nuance, but once you know the trick, it's very useful. So, and you can also set the attributes several times. So, calling the constructor is same as calling the configure mock. And the way you set deep attributes is you literally just put the path there. So let's see how it works. Remember, I set some attribute dot value to 5 and gauge to 7. And then 5 is indeed dot value dot some attribute dot value, and 7 is just a thing dot gauge. So that worked, right? I can set any number of properties at the same time and they can be deep, right? This is again very useful when you want your object to pretend to be something very specific. And now we'll again do an exercise, and I will pause the video for a few minutes, and you can watch neutral stuff while you work on the exercise. And we will come back after in 10 minutes, and I will solve the exercise so you can see how I approach that. Hi everybody, welcome back. I hope you had some success dealing with exercises, but whether you did or not, it's okay. At least you tried, and you'll be able to follow what I'm gonna do much better and see where you got stuck and what part you were missing. So as before, my first step is to actually run the test. So I'm gonna run the test. And here there's only one test and it failed. Okay, so I actually do have to do some work. And let's check the failure. Okay, clearly dot value dot under add is so. I'm adding 1 to x dot some attribute. And I need to get 2. And I need x dot, so I should, so if I'm expecting 2, then x dot's value better be 2. Whatever it adds here, but look, the x here is like whatever it's here, so if I try to do x dot value equal 2 equal 1, right? Then that's not useful. What if I do x dot some attribute equal 1? Okay, that's even worse. Object does not have attribute value, right? So I don't want x dot some attribute to be equal to 1. I want x dot some attribute dot value to be equal to 1, and now that should work, and I only change the line that's b. And now the next test is literally the same thing, but now it uses configure mock, and I'm only allowed to change this line, so I need to do this thing inside the configure mock. So we talked about how we set the properties, right? And I already know what property I'm supposed to do, right? Like I literally have it written here, so I can literally copy this, copy, paste, and I want to set it to the same value here, 1, and now it has passed. So the reason the first test, I did the first exercise is to kind of figure out that this is how I don't want to set it, but now I know that I can set it from configure mock via the kind of pseudo keyword arguments that you get. So to summarize here, you should probably name your mocks. Naming your mocks makes it much easier to understand when tests have failed, as you can see even from the exercises. And you can set properties and d-properties on the mock. D-properties are somewhat misnamed because they're not really properties, the properties of properties, but it is good. It is a good metaphor, and as you can see, it's actually useful in the API. So now we're going to have 10 minutes of break time, and so this video again will I will pause and put some neutral stuff, and I will see you in 10 minutes. So goodbye, everybody. Hi everybody, welcome back. I hope you had a great break. And let's get back into mocks and we'll do some more advanced stuff with them. So we'll start with working on the return value. And because of the duck typing, usually what we want to do with mock objects is to call them, and even more commonly call methods on them, because often Python functions expect an object with a method on it and they will call it, and you want to control that return value. So it's useful to know that a mock object returns whatever value is in its return value attribute, and like any other attribute, this is an attribute that it already has and will be a mock. And we already saw that it returns a mock, but here's kind of a better way to see that, right? Like we set that the return value, which is a mock, we set its some attribute to 5, and then we check what happens when we call the object. When we call it object, indeed we get here, right? We get 5 when we call it, and then take the sum attribute of it. So it does indeed return the value in return value, and like any other case of deep attributes, you can just set it in the constructor directly. You don't need to first construct it and then fix it. And here we go. This is the same test, we just constructed it correctly to begin with. And in general, this is a better final form for your tests because you create the mock object correctly to begin with instead of making an object and then fixing it. But this is often a better way to prototype tests. So often what you'll do is you'll prototype like that, and then you convert it into a test like that. And you can set the return property itself, and then it won't return a mock. It will return whatever you ask it to return. And for example, if you ask it to return 5, then it will indeed return 5. There we see that. And again, you can set it in the constructor, as always. Right, so we set the return value to begin with, and then do that. And that's all well and good, but usually you don't pass functions. You can, and some, Python functions do take callbacks or various things, so it is useful. But the more common thing is that you want to set something that has a method that returns some value. And here's an example, right? So this object is supposed to have a method called method, and that method should have a return value of 5. And here we can see that indeed when we set it like that and when we call that method on the object, that returns 5. And as an example for when it's useful, imagine that this is a file object and someone is going to call read on it. You can set the read return value to a string, right? So this is kind of the model you want to have in your mind for when this kind of stuff will be useful. Again, setting the return value of a method is a deep attribute, and we already know how to do it directly in the constructor. We just use this syntax. And again, this is the same result. And now if you put all these ideas together, you can set an attribute and the return value of a method. And here's how that's going to look like. So let's say that we want to call a method, and that method is supposed to return another object, and that object is supposed to have some attribute of 5, so you basically kind of tell that story here and give the actual value that's supposed to come out. And as you can see, the test properly failed, so that indeed that assertion is wrong. So this indeed returned the 5, right? And here you can see the 5 is calling obj method and then getting some attribute, and obj method is what happened when you call obj method, and obj method is what happens when you select dot method from obj. So this is what we expect, and this is even more common in many ways. Now, sometimes you don't want every call to return the same value. Sometimes you want different calls to return different things. And well, there are different ways to do it. The most common way is to say, well, I know the order of calls that's going to happen. I'm just going to set them in the right order. Again, if you want to model that in your head, think of like a read a loop around like file.read, right, or read line or something like that, right? You know that it's gonna get repeated constantly, and you know the right order of things to return. So you can assign something to side effect, which is an iterable, and then it will control each call return value. So let's see how we do that, right? So we set different things side effect to 1, 2, 3. And you check that the first call returned 1, the second call returned 2, and the third call returned 4. So we expect these two to succeed and these to fail. And you notice that we won't get here unless these two succeed. So if we get here, we already know that these two succeeded. And let's check. Indeed, we got to this 1, and it indeed checked at 3. And you can see that the 3 we got from calling a mock without any argument. So you can see that we return 1, 2, and then 4. Okay, so that's cool. Here's like a more realistic example, right? Like we want to set read line to different inputs, right? So let's say that we have this silly little parser that reads 3 lines and then tries to figure out some weird syntax. I invented the syntax because real parsers are slightly more complicated, and I didn't want to write a complicated parser. You notice that here, as I talked about it before, I'm using a spec. The best spec to use in this case is text.io base, because this is supposed to be a file-like object that is a text mode. And here you see that I set its readline method to have a dot side effect of here. This is things. But here it's supposed to be to some people, and our parser is supposed to automatically know to convert some to most. So it doesn't do that, and we'll have a test failure. And you can see that we return. Right, like so, the parser did most of the work correctly, and this is a very, very typical thing that you'll do, right? You'll kind of create these like kind of little stories in your read line, in your side effect, right? Which says, you know, first return this thing because this is the first line, then return this, and then return that. So this is pretty cool, right? And this lets you write pretty sophisticated tests. But the ultimate power is just to write code. Now, this is the last fallback. You want your tests to be simple. You don't want to have more code in your tests than you do in your production code, right? And you want your code in your tests to be simple because you don't want the bugs to be in your test. You want them, when the test fails, it probably should be because there's a bug in the production code. But on the other hand, this is like this is kind of like a simplified example, right? We want to test code that doesn't do any computation, right? So let's write, like a little more complicated parser. Now this time the parser reads from a socket, right? So it calls the .make file. It first connects to the socket and sets timeouts, but we're not going to worry too much about that. And then it calls make file, right? So in your head you should always think, that's probably going to be a .return value because it's going to assign it to fpin. And you notice that here it sets order and it randomly shuffles the order, so we can't know. We know that it's gonna call send all get key, and then it's gonna read this line, and then it gets value, and we don't know which order these calls will go because it's literally random. In real life, your test will probably not be actually random, but it might be complicated enough that it's effectively random, and you definitely don't want to encode that order in case you change your code, right? Like your code might not be random, but someone might change it. And here this code has a bug, right? It should be mapping the key to the value and not the value to the key. So we want to make sure that this bug is properly found via testing. And because this is random, right? If you write an insensitive test, right, that always returns interesting, it's it's gonna work all the time, right? But it doesn't detect the bug. And if you write, we use like the iterator side effect, then it's gonna work sometimes. But because it does work sometimes, I want to try it a few times to make sure that that it fails. And you'll actually see that, like, I can predict how many times it fails, right? So in this case, it fails 2 times, right? For 1 and 2. So you notice that it succeeded for 3, 4, and 5. But if we try it again, it will fail for different instances and, potentially more. Right now it fails a lot. And if we try it again, it will fail less. Right, so this is completely random, right? Now it fails for 1 and 5. And before it failed for... And this is a bad test, right? This is a worse test because it's a flaky test, right? It's a test that trains your people to say, that test failure is probably the result of flakiness, not a result of bug. So it effectively does nothing because people will ignore it. This test effectively does nothing because it passes on our buggy code. Right? We want to write a test that will fail when there's buggy code and will succeed if we actually fix the code. So, and because of this, we actually now have to write some logic. So let's see how we write some logic. And this does make the code more complicated. We could, of course, assign the callable directly to the method. It's better to assign it to the side effect. We'll talk a bit more about tomorrow. And in this case, our callable object will kind of poke a different object. So let's see how these tests work, right? So again, let's actually, we accidentally fixed this. So let's put the bug back. But let's look at the test now. So now we have send all. It actually parses the commands here, and if it sees that the name is key, it will say it's supposed to be key, and if it sees the name value, it will return the value, and otherwise it will just raise an error. And that's good because that means the test will fail, right? If I misspell the word key here. And then I assign it to the send all. So you see that this sets the sock.makefile.return value.readline.return value, right? So it changes the value of the sock makefile return value readline send all, and then it asserts that it actually gets the key value, and that will fail. But you notice that it will fail no matter how many times I run the test, right? It always fails because now it always, and if we fix a bug, right, if we do indeed, sorry about that, if we fix the bug, then it passes, right? So now the test is reliable, right? So it is a more complicated test, but it's not too complicated, right? Now it's gonna reliably fail again, and that's what you want. You want a test that fails if you have a bug and succeeds if you don't have a bug, right? That's the ideal failure. That's the ideal test. The final thing I want to cover is call args and call args list, which are slightly more subtle. In the call arguments, you want to make sure that the code, calls it with the right arguments. So let's assume that you're automating some data center manipulation and you're writing some parameter automation, and so this is our little parameter automation code, right? And it's going to have a subtle bug. This is important, right? Because we want to make sure that, well, obviously, like in real life, we won't intentionally put bugs in code. But in this case, like this is a production code, right? And it has a bug. And I'm not going to tell you what it is until we kind of dig in a little bit more. But let's look at the tests that we write. So, the exact command is going to return these values, right? str. So, it's just going to return 1, 2, 3. And we go, and this is, it's supposed to compare to return value, right? So that's And we go, and let's see what happens when we actually do that. So you see that this test fails, right? It has found a bug in our code. But you notice that the only way I could find the bug is by checking call args, right? If I just checked that the result is correct, then the test passes, right? Even though I have a bug. So what's the bug? Let's see. What happens is that we called ls minus l a file, right? Because it just interpolated it, and this is the argument list. And indeed, this is be a bad command to ls, right? We want to ls the size of a file, not a in a file. That will probably be wrong. So, but the way we found it was by checking the call args list that it sent exec command, right? So here it's exec command, right? We checked that it calls args, and we checked that we indeed expect ls minus l and fname. Right, so so this is important, right? We kind of make sure that like our code that actually creates a command creates a correct command, right? So we expected ls minus l a file, and we got this. So this is not good. And ideally we'll fix the code. And this is a very good example for a test that has to check the arguments that a method is called with to see what's going on. So sometimes this is not enough. You actually want to check .call args list, which gives the entire history. So here's an example, right? By the way, this is a real website that will perform remote calculations for you. Let's suppose that you have this production code that for some reason, instead of squaring numbers on its own, it will do that. And the way it calculates a cube, even though this API could actually calculate the cube by itself, it first does multiplies base by base, and then takes that result and then multiplies that by the square. So not the most efficient, but it does work correctly. So let's check that it works. So in this case, but we want to check that it correctly orders the base and the square, right? So let's check that it does the right thing. Right, so as you can see, our test wants to make sure. I forgot to install Httpx. That's okay. Easily solved. Let's pip install Httpx. And as you can see, like I installed Httpx, even though I'm not actually gonna, of course, run the code in the like run actually network code, but I need it because otherwise I won't be able to use the right spec. And specs are very important, as we have discussed. So now it should fail correctly. And as you can see, it expected 25 times 5 and 5 times 25 because it wants to make sure that the bigger argument number comes first, because it assumes that this is going to be more efficient. And obviously this is a little bit silly, but this shows you that why we need the call args list, because we need the entire history here to make sure that we know what happened. So this is a very typical example, and now I'm going to let you work on this exercise, and I'm going to come back after this exercise, after you solve this after you had 10 minutes to solve this exercise, to solve it with you. So I'll see you in 10 minutes. Hi everybody. So welcome back. I hope you had some luck working with the exercise. As before, it was still very silly, but now we want to have a test where, again, the arguments are in a random order, and you want to make sure that the arguments are still correct, but they are in some order. So here's, and again, because it's the code is random, we're gonna try to run. So again, as always, we first try to run our tests as is to see the failure. And again, you can see that like it only it fails probabilistically. So in this case, it only failed 1 time out of 5, and now it fails 4 times out of 5, right? So it's very very random, right? As before, again 4. But this time only 2. You might have run it. I'm not actually sure how many of you there are, but if there's more than 16 people, then probably at least one of you tried to run it and it succeeded all the all 5 times. So hopefully you tried running it again. In any case, this test is wrong, and the reason it's wrong is because it assumes that the expression is going to be 625 times 55, and as you can see in the time it fails because it's 5 times 65. So there's a few ways to fix it, but one way is to just add r x per equals 5 times 625, and because I accidentally had a space. So yeah, and now all tests pass. And in case you're wondering whether I'm just particularly lucky, this would require enormous luck to actually have twice. That's kind of 1 in 64, and let's just make sure that you really think this is not just my luck. So anyway, obviously there's a few other ways you could split the expression by like another way of solving is to do like something like set of dot split of star equals go. Right, so I hope some of you figured out that you can also do that. Equal, of course. Here we go. So this is also a completely valid way to fix it. So there are a few different ways to fix it. The most important thing is that you kind of see how to think about these things and how to work. I did put split here to kind of remind you of the existence of this function. So hopefully that was a nice reminder. Either way, whether you did it via or equal, or maybe you figured out a different way. Maybe you did like start with or and end with or something like that. These are all valid ways. So hopefully you got it to work. Awesome. And now we have a few minutes before we go. So I wanted to give you some final thoughts. So kind of just a reminder of what we went through. Assertions let you verify conditions. Mock let you avoid interacting with real life. You can set the mock attributes, return values. You can even fine-tune their behaviors. And mocks do record the arguments they were called with, and you should check those to make sure that the calling code did things correctly. The final thing that I wanted to talk about, I didn't talk about this in this exercise, but in this talk at all, but this is kind of like the background for the talk maybe. As you're writing code, now that you know how tests feel like and look like, think about how would I write the test for the code? Will writing tests for this code be pleasant or a pain? And if it's a pain, try to think about how to restructure your code so it's more testable. This will make your code better. Usually it will just make your code better as is, but either way, it will get you to write more tests, it will get your colleagues to write more tests, and it will get you to have higher quality code. So especially the power of mocks shines when you pass arguments to functions or constructors. You should do it more. when you create something in the constructor, you're locking down your code. It makes it harder to test. When instead you accept it as an argument from the outside, someone can send in a mock and be able to make sure that it works. It does require thinking about it. I didn't cover patching at all because I already had a full talk. But in some sense, I don't want to cover patching. If you have to write a patch, that means your initial code was not really written to be testable. Think about whether you can just fix your code instead of working around it. Sometimes you can't. Sometimes there's a lot of code and you have to patch. If you do, think of it as a code smell. Think of it as something that a tech debt that you will have to pay down. And I'm not sure how much time we have for Q&A. That kind of depends a little bit on how the video will work. Hopefully you get a chance to chat with me while watching this video. This is one advantage of pre-recording this video. But if not, just feel free to reach out, and I'm happy to talk to you about this later. So goodbye. Thank you all for attending this tutorial. It's great to have a chance to talk to you about how to write tests. And I hope you all get a chance to implement these things in your life. Goodbye.